I don't understand myself quite why I have clay, silt, and sand in here, and I'm going to have to check that. It shouldn't be there, but for the moment, I'm not going to worry about it. This may be that this file is just something that's here for inspection. In any event, we see, I'll look at that in a few moments, but we see how this goes. How many loads? Where are the loads? What are the loads?
And quick question, Carl. You just go up to the top. And the question I'm going to ask is, and it's probably explained in the documentation. Oh, sorry. Go to the first actual load values. I'm sorry. And I was going to ask if you had, for example, 1, 2. Right now you have 1, 2, 3, 4, 5, 6, 7, 8. So if you had 9 loads, you would need to use a second record. So on the second record, do you still specify temp and 0 and then the 9th load, or you just leave those first 2 fields blank and you put...
You leave the first 2 fields blank.
Okay.
Yeah. The format statements to read these things are wonders. Tom really was great with...
Right, yeah, that kind of stuff. Okay.
They're wonderful.
So what we're looking at here is a file that you need a file for every time interval at which you specified load. So you have a monthly file, a daily file.
You could have an S1 file, which is daily, and an S2 file, which is monthly.
I'm looking at the sequence here. You have day 0 here, and then you're reading down, and all of the next loads are 30.4.
Right.
Okay. Do all of the next loads have to be 30.4 in that sequence, or?
Yes.
Yes.
Strictly speaking, the only time it reads is that first one, that's the temp. That's the first variable. It reads at 30.4. The other 30.4 is in the file for the other variables, but it's just a placeholder. It doesn't actually read that.
Right, because it's only using temp. But if I had a run that was using all of the, or more than one of these variables, then I need a line for each variable. The line for each variable has to have a J day on it. The J days for each group all have to be the same because it reads them all at once.
That's correct.
So I need blocks of the right number of variables, which would be the number of specified variables, or the number of active variables. Is that correct?
Right.
And they all have to be the same day,
That's correct.
whether or not there are loads.
Was it?
Whether or not there are actually loads.
Yeah.
Okay, so this file is a series of blocks. Each block has enough lines to contain all of the active variables.
That's correct.
Okay.
So even if you wanted to update one variable, you'd still need, yeah.
So if you want a new active variable, you got to modify this file.
Yeah.
So you have to have a utility to modify this file.
We will, well, I guess on Thursday morning, now take away the guests, Lord willing, on Thursday morning, we're going to talk about the specific processor we use to make up the watershed model files. And that processor is distributed with the material. So if you want to do something different, there's a start.
The other thing is, okay, so I've got a bunch of these files, each one of which has a different series of time steps.
Potentially.
Dates to read. And when the model knows which file each one is in.
Well, you give it the names. We'll look in a few minutes. You give it the names of the. We've said you have potentially 3 files: S1, S2, S3, and they can differ in terms of their nature. They can differ in terms of their frequency of input. They can differ in several ways. All we've said is these are S1, S2, S3. In this control file, you have to tell it the S1 file has this name and is located in this
Right.
place.
But do you have to tell it what variables are in the S1 file?
No, because it's going to read 36. It's going to read the 36 variables.
All of them.
All right, let's
Go up to your header.
let's go back. Okay, we go back to the header. It's going to read 36. But
In that file, but if in this file, I don't have all the active variables, it won't read all the active variables in this file.
it will always read this field, or
It will always read
for
36
all active variables.
from each of the S1 files.
That's correct.
So, all of the active variables are in all three. I'm just trying to understand. All of the active variables are in all of the S1 files. But the time specifications are different. So, it's going to get 3 next dates for the same active variable, no?
It'll get 3 next dates for, it'll get a next date for each file, S1, S2, S3.
I see. And so, if it all right, so it gets 3 next dates for S1, S2, S3. But what happens when I'm really setting the loads for something in S3, but it also exists in S1, and it reads in S1, does that update the load that I'm setting in S3?
No.
Why not?
Because they're separate inputs. You know, when we had that conservation of mass equation, the very last thing was something like a sigma SI. And I said that these were the sum of internal sources and sinks.
Understand. I'm not asking about that, I'm asking about the mechanics of the read.
Yeah.
So I'm worried that I'll have set on February 15th a load here that I want to go through. Say I've set a load here on I'm doing it weekly, on the 27th of January, and my next date is 7 days later. But that's after it reads for the 30th. Do I have to have the right load in the monthly file that corresponds to the weekly file, or does it read the loads from just one of the files?
It'll read the loads from both files, but it keeps them separately. It keeps them separate.
Oh, I see. So if it's 0 in one file, if I'm only setting it in one file, I have to set zeros in all the other files.
That's right.
Now I understand. Okay. I got you.
Okay.
I have a question about the temperature and salinity load. Its temperature, is it going to be heat or just the daily volume multiplied by degrees Celsius?
There's 2 ways you can do it. If you think about on rare occasions, we have actually had temperature loads. Discharge from power plant tends to actually come out as a thermal load, if you will. The temperature equation, in a sense, it's how should I put this?
It's the same argument you're going to use for pathogens. It's going to be the concentration units, irrespective of whatever they really are. I mean, we say it's kilograms, but you basically just take your flow times whatever your concentration of either temperature or whatever.
What about salinity and is going to multiply the
Salinity parts per
concentration or
thousand.
not the concentration? Does not convert.
Well, no, suppose you were going to have salinity coming in from suppose you had
some place,
what do you call it,
let's say
a desal plant.
Yeah.
Then you would take your salinity in parts per thousand, because that's the units the salinity is in, and multiply by your flow.
Okay.
It's it's when pathogens used to be a variable in this model, and I had a little bit of code in there, so if you got them as most probable number or something like that, it would do it right. Jim has given you an approach. If you don't want to go into the code, Jim has told you how to do it. For temperature, the one time we did a power plant, I actually went into the code a little bit and made it deal with heat. These loads are assumed to be kilograms. They're kilogram per day. By the way, let me mention, I suppose it's in the manual, but it assumes kilogram per day. So if you wanted to have kilograms of temperature, you know what I mean, you could work something out, or you could do it right. I'd prefer to do it the right way.
Oh, so I was wrong. If your temperature is in degrees Celsius, you don't multiply it by the degrees Celsius times the flow. You actually try and how would you calculate a kilograms of heat? Oh, so you would put it in as kilograms of heat. So my answer was wrong.
Yeah, I have to ponder some of this.
All right.
If you have a thermal,
I would do it. Okay.
if you have a thermal load, you know.
Just want to clear it off.
Okay.
You know, there's heat load.
I may have told you wrong then.
If you have a thermal load, call me and we'll work it out. How's that? But, you know, I mean, as I said, the one time we really did this, I worked it out in, I don't know, BTU or whatever the heck, actually we don't, well, anyway, we'll defer on that. Kyle, I see the hand. You know.
Yeah, building off of what Dan was asking, if you had something like a randomly pulsed load, I don't know when this might occur, maybe it's like a sewer overflow or something, would you have to define that as maybe as the daily input, just if you were trying to save space, you would have a separate S file, or it has to go in daily because it's 0 every other time?
Let me, what's the question, so to speak?
Yeah, so I understand like the monthly, like it's set for, you know, each day onwards, but if it was something like just a random interval, would it have to also go into that sort of daily file so you could have 0 the following time step?
I'm not sure I understand the question.
Here's what I understand and tell you if I'm wrong. You have 3 input files, so you have 3 time schemes.
Yes.
Okay? You have to input it in one of those 3 time schemes.
Right.
So if you are only using daily and monthly, you have a third one which can be irregular. You could put it in the irregular time scheme.
Okay.
Am I clear? That's what I think I heard.
Yeah.
Is that the question?
And by the way, if you really wanted to get down to detail, you could have the flows at, you know, they don't have to be at daily intervals. You could have that combined sewer could come in at, you know, start at midnight and end at 2 a.m. You know, you could take 2 a.m., convert it to whatever that is, 0.16 days or something, and turn it off at day 0.16. I got 2 things I got to look at, but anyway, okay, so where are we in the PowerPoint? Let's go. Oh, well, this is pretty much what we just went over. We have to give it the number of loads for the 36, you know, the dimension of number of constituent parameters was 36. So over here, this had to be, we had to give it 36 of those.
Except you only have to give it the active loads.
Well, you have to specify the number of loads for 36 variables. If it's not an active variable, this has to be 36. It's just in the code. I don't know, a variable that isn't active is urea. You have to tell it there are no urea loads, even if the variable isn't active. When you get down to here, only active. Since urea is not active, it doesn't appear. Call it illogical, call it what you like, it's what is. So, you know. So for example, yeah, non-point source load box. There are 28 active variables in the Bay model, so we specify 28 of them. Okay. Okay, boundary conditions file. Well, let's open her up. This is the devil too. Well, hell, life is. Okay. So boundary conditions. Now, boundary conditions are at those open faces, the places where there are two zeros. The Susquehanna, in the bay, the Susquehanna River is a boundary. The ocean, all that ocean is a boundary. We will, again, on, I guess, Thursday morning, we will actually look at the real Chesapeake Bay boundary conditions, and we'll look at a processor that creates the files. But for now, let's just go over this. So the first three lines are header information, just title, you know, if you want to remember something. You need to know the number of flow faces at which boundaries are specified. You know, how many open boundaries are there? In this file, the only thing that's read is this. There were 4. That other stuff is relic information. It doesn't mean anything. But you have to know there were 4 open boundaries. And in the 30 box model, they were the one place all the way on the left, which represents the Susquehanna River. It was only 1 deep. Remember, there were closed faces below that, and then on the other end, it's the interface with the ocean. Okay, so there are 4. Then you actually put in the actual boundary conditions for all active variables. Active. There were 28 active variables, so there should be 28 boundary conditions. Okay, not 36, 28, which is the number of active variables. Okay, so, and here, for example, on day 0, we have temperature, salinity. These are all the boundaries. On day 30.4, here we go again. And apparently I do have, I need to go home and look at that G3 file, that load file this evening and make sure it's right, straighten it out. For now, we won't worry about it. Okay, so be it. There were a couple of things, there are two things I'm going to cover. Okay, let's look simply. For any number of these, okay. Temperature, for example. Let's start with temperature. Okay, so remember our 30 box model. We had 1 open boundary here, which was the Susquehanna River, and we had 3 here, which were the ocean. And that's our total of 4. For temperature, you'll see that we specify 1, 2, 3, 4 boundary conditions. So we specify temperature at all of these open faces. For salinity, it's not so obvious, but we specify 4 of them. The salinity in the Susquehanna River is 0. Now we get to, let's take, for example, dissolved organic carbon. 4 boundary conditions. The dissolved organic carbon at the Susquehanna River is 0. Is it really 0? No, it isn't. Why do we do this? We have 2 ways of loading the model from the Susquehanna River. We could give it a load. We could put it in the S1 file. Or we could give it a boundary condition, and the model would take the boundary condition times the flow. You can do it either way. Convention. It's just convention. The things that are loaded, loads that come from the watershed model, we treat as loads. And therefore, we give them 0 for the boundary condition. So for the carbon, the nitrogen, the phosphorus, the boundary conditions at the inflows are 0 because we load it. For things that we don't think of as masses, for things that don't come from the watershed model, temperature, dissolved oxygen, these things, we give them actual boundary conditions. So for example, here's dissolved oxygen. It's 8 in the Susquehanna River. It's 11 at the ocean interface.